Okay, so there is an indeterminate form that goes like this. If you have infinity minus infinity, this is one of the indeterminate forms. In other words, we can't tell what that limit is. Now, both of these two problems have that form. Notice, in this one right here, you have the limit as x goes to 0. This term right here would be infinity, and this term over here would be infinity as well. So you do have, if you evaluate 10 over x as x goes to 0, this is infinity. Also, this one's infinity. So this is infinity minus infinity. Now, let's see if we can use L'Hopital's rule. So what I want to do is add these fractions, because remember, I need one numerator and one denominator. So here I go. I'm going to see if I can use L'Hopital's rule here. So here I go. I'm going to take the limit as x goes to 0, and I get a common denominator, which is x squared. So I've got 10x minus 3 over x squared. Okay? Now, let's see what happens. If I take the limit of the bottom, I get 0. The limit of the top, I get negative 3. L'Hopital's rule does not apply. So we can just stop right there for this problem. L'Hopital's rule does not apply. Because when we did get to the point where we had 0 over 0, or a numerator or denominator, L'Hopital's rule, it didn't meet the criteria for L'Hopital's rule, so we stop right there. Now, if you want to find this limit, L'Hopital's rule is not going to be there for you. What you're going to need to do is you can find that limit numerically by plugging in closer and closer values to 0, very small, getting smaller and smaller x values, or you can look at the graph. Now, let's look at 1 over here. This is also, if you put it as x gets closer and closer to 1 for log x, well, log x gets closer and closer to 0, so 1 over log x is infinity. So you got infinity for the first term, and likewise for the second term. So you got infinity minus infinity for this one. Now, we want to see, can I use L'Hopital's rule? So I'm going to add my fractions. So here I go. I've got, this up here needs x minus 1. So I've got x minus 1 over x minus 1 log x, minus, this needs a log x, like that. Now, I've got the same denominator, so I can add the numerator. So here I go. I've got the limit as x goes to 1. I've got x minus 1 minus log x all over log x, x minus 1. Now, if I plug in a 1 up here, notice I get 0 on the top and 0 on the bottom. L'Hopital's rule is going to apply because I've got 0 over 0. Once I did get a numerator and denominator, I can see I've got either infinity over infinity or 0 over 0. In this case, 0 over 0. So now I can differentiate the top. So the top, the derivative is going to be 1 minus 1 over x. And the bottom, it looks like it's going to be 1 over x times x minus 1 plus log x. See, I took the derivative of the first times the second plus the derivative of the second. The derivative of the second is just 1. Now I think what I'm going to do, I've got this extra, I've got this extra x here. So I want to clear that out. So let me just multiply the top and the bottom by x. So here's what I've got now. So I've got the limit as x goes to 1. And let's see, I've got, I need to multiply this by x as well. So I've got x minus 1. And down here, I've got x minus 1 plus x log x. Okay, now let's see if we can tell something here. If I put in a 1 up here, I got 0. If I put in a 1 down here, I get 0. So let's take the limit again. L'Hopital's rule again. Okay, so let's see, the top is 1. Okay, the bottom, let's see, this first one is 1. See, this derivative here is 1. Plus, let me see here, derivative of the first is 1 times the second, plus the derivative of the second times the first. See, so I took the derivative of the bottom, and this required the product rule. So here's what we get now. We get the limit as x goes to 1 of 1 over, let's see here, this is 2, right? This one and this one is 2. 2 plus log x. Now, if I plug in a 1, I get 1 over 2. So that's the limit, 1 over 2. So dig this. Here's what I'm going to say. Whenever you see a situation where you have infinity minus infinity, as is the case with both of these, that doesn't mean that L'Hopital's rule is going to work for you. What you'll know if L'Hopital's rule is going to work when you add the fractions, get a numerator and over a denominator, if you have 0 over 0 or infinity over infinity. That didn't work out here, but it did over here. And notice here we've got our limit, 1/2, and here we were not able to determine the limit. So that's a difference in those two.